come around and check that in a little bit. But what questions from the homework would you like to go over with adding, subtracting, multiplying, polynomials? Or the last group of problems where you were solving those equations. Peter? Yeah. So the group of problems, the last group of problems you were assigned, wanted you to solve the equation. The first couple equations were linear, and then once you got to 68, the equations became quadratic. 69 says w squared minus 15w plus 54 equals 0. And we now know that there are a couple of different ways that you can solve this. Factoring would be one way to check completing the square. You can use the quadratic formula. Using square roots doesn't really work because there's not a quantity in parentheses that's already like factored form or in that parentheses square. Peter?
Is it plus 52?
It's plus 54. Oh, so maybe that's why? Okay. Does anybody know what method you would use? Chris? Yeah, factoring is probably the easiest. Completing the square would work, but it might be a little messy with some fractions. But factoring would be the first way you want to try. So Chris, the two numbers that multiply to be 54 but add to be negative 15. Yeah, so you're looking for two numbers that multiply to be the last number. So we have a positive 54, so those two numbers will be a negative 6 and a negative 9. And then placing them in factored form, we can just put those directly in parentheses because the coefficient in front of the w is just a 1, w squared. And then it's equal to 0, so solving it, each parenthesis gives you a solution. That's the zero product property. So when you're taking two products that equal to 0, you can solve those products individually. Yeah, 52 would make it a little difficult to get the answers that are... Yeah, that would be the only way that would probably work somewhat nicely. Other questions? I will come around and check that though. So you can just keep it on the corner of your desk. Probably when you're taking your quiz, I'll just pop it. So as I said, we're going to go through a handful of questions today, showing you how special patterns work. You don't have to use special patterns because you can always FOIL or multiply. So that's always the option that you have to use. However, the special patterns sometimes save you a little bit of work, especially when you're dealing with something that's cubed. So this might shorten the amount of work that you have to do instead of multiplying a group of parentheses together. So yesterday we looked at the sum and difference. So when I have m plus 3 or m minus 3. And then we looked at the square, the perfect square pattern. So we did the sum and difference yesterday, and we did the square of a binomial. And again, you don't have to use the patterns. You can just FOIL them out if you choose to do so. Once we get to the cube, the pattern gets a little bigger because this is something that's now cubed. And if it's cubed, it means I have 3 parentheses. When it's squared, I have 2 parentheses. So the pattern for a cube says I have a cubed and then 3a squared b. So essentially you're losing one exponent as you're working through the pattern. The next one says plus 3a and then the b is squared, and then the last one is b cubed. So looking at my a term, the a power decreases, and looking at the b term, the b increases 3. Now the problem with the pattern is that it's a pattern that needs to be memorized if you're going to use it. Otherwise, you're going to just have to FOIL. So I going to show you how the pattern works. This first one says x plus 1 cubed. So one option would just be to write this 3 times. Foil 2 of them together, like we did yesterday. And then after you foil 2 of them together, you're taking that product and multiplying it by the third. So that's option number 1. Option number 2 is to try and apply the pattern. So my A term is x and the B term is 1. A pattern works like a plug and chug. So it's like a little formula. You're taking values, you're plugging them into the formula. So it says a cubed. That means I have x cubed. So I'm just plugging the information into the formula. And then there is a 3ab, and that a is squared. So a squared is really my x term. And then b is a 1. And I'm going to place that 1 there even though it doesn't really do anything because it's a 1, but just to have that in the problem. And then it says take 3a and then b squared. And then finally we have b cubed. So I would have 1 cubed. So if I simplify that a little bit, I would have x cubed. 3x squared times 1 is just 3x squared. 3x times 1 squared is just 3x. And then my last one is a plus 1. I can get that same answer, the same product, by foiling. So I can also foil and arrive at the same solution. So this is just giving you an option or another way to calculate, another way to multiply by using a pattern. But you don't have to. So the second one underneath is the difference. And you see when it's a subtraction sign, the signs flip. So I start with the minus, then it goes to a plus, and then I have a minus again. So they're kind of using a pattern here of the minus plus minus because of this minus sign right here. Yeah. So see if you can try and apply the pattern. So we have a minus b cubed is a cubed minus 3a squared b plus 3ab squared, and then minus b cubed. So try and apply the pattern. The r would be my a term, the 3 is the b. The minus sign is not part of the 3. The minus sign is how I get the signs in between my terms. So just using the a is now r cubed. And then it says minus 3a squared, so r squared, times b. b is 3. And it's a plus, another 3. Now it's just a and b squared. And then the last one is minus b cubed. So again, the power of the first one should decrease. So it starts as cubed, squared, and then it's just r. Where the second one goes the opposite way, it starts out as a 3, and then that 3 is squared, and then that 3 is cubed. So Nina, if we simplify this, what is our final product answer or solution?
Would it be r cubed minus r 3r squared?
So you're close, but we have a 3 in the front and a 3 in the back. So that would make, if I multiply those two together, yeah. So that's negative 9r squared. And then looking at the next one, there's the 3 in the front and then 3 squared. So that would be
Wouldn't that just cancel it out if it's like plus 9r squared?
that term is a different term. What does that become? So I have 3r and then 3 squared.
Oh, 3 squared. Okay. That would be plus 3.
About 27.
Okay.
And then it's just r. And then 3 cubed is cubed. 27. So r cubed minus 9r squared plus 27r and then minus 27. You can choose to just do r minus 3, r minus 3, r minus 3. It's just a little bit of work that way. So if you have the pattern to look at and to plug in, it makes it a little easier. But if you're using it on a test, you will never be given formulas, especially algebraic ones. So if you're using it on the test, you have to have a pattern. So,
Do we need to remember this for the test?
if you use it, if you want to use it, yes. I will never give you formulas for anything. So you don't have to use it because you can choose to just write it 3 times and foil.
So that will work for any cube.
That'll work for
If it
any
doesn't
cube
have
problem.
something
So anything that's like whatever cubed, it'll work. Yes.
special. And that's the same for squares.
Yes. Yep. So looking down below, I think there are 4 problems down below. So just trying to use those properties. So the first one, it says use special patterns. So try and use the patterns just to see how they work. So the first one, I have the difference and the sum, or I could say the sum and the difference. So that's the first pattern, the sum and the difference. And it says the sum and the difference is just your 2 terms. You're really squaring them. So you're taking the A term and the B terms, and technically we're squaring those values. That's the first pattern. It's a minus sign in between because a plus times a minus makes a negative. So if I apply that property, 7m minus 3 and 7m plus 3, Ava, if I use that property and do A and B,
It would be 49
yeah, 49,
minus 9.
you're so close. What variable goes with the 49? M squared. Did you say M? I just didn't hear you.
No, I didn't.
So my A term is 7m. So that means I have to take 7m and square it. My B term is 3 squared. So A would be 7m times 7m, which is 49m squared. And then the B is negative 3 times 3. The second one, we have 4t cubed plus 6. So my pattern, this is then squared. So if you look above, it might help for you to write the pattern underneath for you to follow. This is the pattern right here. So a squared plus 2ab, and the 2 is because you're multiplying it through twice. And then it says plus b squared. So this is supposed to equal a squared, 2ab, b squared. And all of this is a, and the 6th part is b. So 4t cubed, following my pattern, that's squared. So whatever I have for a, that has to be squared in the pattern. And then it says plus 2 times a, which is 4t cubed, times b, which is 6. So I'm taking the values, plugging them in for the pattern. And then the last part says plus b squared, so plus 6 squared. So Gavin, 4t cubed and then squared. What would that become?
16 cubed is 6.
Yeah, so square the 4, and then the exponents, you're multiplying those as well. So t to the 6. The middle term, Gavin, 2 times 4 times 6 is 48. And then we have the t cubed. And then 6 squared is 36. Questions? So the third one is the cube problem. So again, this here is A, and here is B. So A cubed, it's a minus, so my minus goes first. 3 The A decreases, and I have a B. Now it's plus, again a 3. The A decreases, the B power increases. And then my last one is a minus, and it's B cubed. So the first and the last are A and B cubed. The signs switch, they alternate. So a minus, and then a plus, and then a minus. Just try and plug them into the pattern. I put everything in parentheses when I plug it in. Kind of separates it and lets you see where the A, the B terms are. So Nick, x, y quantity cubed is,
X cubed, Y cubed.
and then my second term would become
Negative 12x squared y squared.
the third term,
48xy.
and then 4 cubed is
6 as well.
6. So if you flip the page, I just want you to do the 2 problems that involve the cube and the square. So just look at 3 and 4. So just trying to apply those patterns, getting a little more practice with the patterns. So when you have a plus with a sum of 2 cubes, we have a cubed 3a squared b plus 3ab squared plus b cubed. So when you plug all that in, Ava, what did you get?
X cubed.
Oh, it's x, not z. Why do I have a z? Oh, I don't know. I like z today, apparently. X cubed.
Plus 6x squared. Plus 12x.
Right. I don't even know where I got the z from. My x's are supposed to be. My z's are supposed to be x's. And then for number 4, this is a difference. And I have that perfect square. So make sure you have a difference in your formula. Chris, what did you get?
I got 4x to the 4 minus 12x squared y plus 9y squared.
Nice. So next week, we'll be factoring these guys. Yeah. We're going to go backwards next week. So kind of think about how to multiply it. You see how the pattern works, so that next week we'll come back and check. So I have a little 5-question quiz. When you're done with your little 5-question quiz, just on exponents, not multiplying, dividing, or not dividing, adding, subtracting, or doing dividing. Turn the little quiz in. I can give you your worksheet. Keep your homework out so I can come around and check it.